Okay, so that's your question. You want to find what is A and B. Okay, so for this question, right? You first expand both of the brackets, so you have 3ax minus 2a plus 5b minus bx. And now you have to group up all the terms with the x. So we have 3a minus b times x, and then minus 2a plus 5b equals to 11x minus 16. So that means that 3a minus b, this one, have to be equals to 11, right? And then we have this 5b minus 2a equals to negative 16. So now you have to solve the simultaneous equation. Can? Do you know how to do simultaneous equation? Okay. There's supposed to be one more student, but haven't joined yet. Maybe we wait like 1 more minute. Okay, so maybe we just start first. Let me erase this. Okay, so have you watched the video for today? No? Okay. I will just go through quickly on what this topic is about then. Okay, so today we are actually going to learn about quadratic functions. Have you learned in school? Yes, okay. So today we are actually going to be talking about how to complete the square, and then we are talking about how to find the maximum or minimum value of a quadratic function. Okay, so when I have a general quadratic equation of the form ax squared plus bx plus c. Okay, so this is what we call the general form of a quadratic equation. So quadratic just means that you have the x squared over here. What we want to do and we want to complete the square is we want to turn it into a form that looks like this. We want it to look something like this. So how can we convert from this form over here to this form over here, right? So first step whenever we do completing the square is to factorize such that the coefficient of x is 1. So for this case, when we have the ax squared plus bx plus c, we want the coefficient of x squared to be 1, right? So we need to factorize out the a. Okay, so to make it easier, I'll put ab here lah. So that when I factorize out, I will get a bx here. Okay, and then when we compare what we have over here to what we have over here, we want to transform this into this kind of form. So when we expand out this x plus b squared, from your A math, I think this one you should have learned, E math, you should have learned the expansion of this kind of formula is your a square plus 2ab plus b square, right? So this thing square plus 2 times the first term times the second term, then plus the second term square. So you will get x square plus 2dx plus d square. So when you compare here, when you compare here to over here and here is the same. Then how about here and here? We want these to be the same as well. So that means that the 2d and the b have to be equal. Okay, so this just means that whenever you have this kind of formula, your b you always just need to divide by 2 to get this number over here. Okay, so to give an example, right, I will just do the first question over here first. When you have x squared plus 6x, and I want to complete the square, I just change this to 3 because 6 divided by 2 equals to 3. So we will always just divide by 2 because of the nature of the extension being that when you extend this out, we will have 2 times x times 3. So you will get back the 6x for the middle term, right? So you will get back this 6x. Can understand? Okay, so the trick to completing the square is always the term, the coefficient of x, you always just divide by 2. Okay, but then after that, going back to our previous part here, we haven't finished yet. There is still a plus dx, plus d square that our original function here don't have. So you need to minus the d square from our expansion. So for here, second part, x plus b over 2 square, you need to minus your b over 2 square. Because here we have x square plus 2 times b over 2 times x plus b over 2 square. So we need to cancel off this one. So we minus it here. Can understand? Because here, right, matches over here. So here and here is the same. Okay. So after that, you still cannot forget that we have the plus c over here. So remember to put back your plus c. Then it will be a times x plus b over 2 square minus a times b over 2 square plus c. So this is how we get the completed square expression. Okay. So another thing you need to know about quadratic equation is that when we have this general form of ax squared plus bx plus c, if a is positive, then the shape of the graph will be like this. So sometimes people call this happy face curve because it looks like smiling like that. So if a is negative, then it will be the sad face curve, which is like this. Okay? And then whenever you do the completed square expression, when we have this form ax plus b square plus e, the vertex. So what does vertex mean is also the turning point. Meaning here and here. Okay? So the vertex, the coordinates is always like this. So the x coordinate is from here. You just need to change the sign. So if here is positive d, here will be negative d. Okay. Then for the y coordinate, you get from here. if here is positive E, here will also be positive E. So this one you need to change the sign for the X, but Y you don't need. Okay, so we can do some practice now. So over here, just now I went through the X plus 3. But then we still need to minus the 9 minus 3 square. Right. So to check, we go through. Here is x squared plus 2 times 3 times x plus 9 plus 3 squared. Then after later, I minus off the 3 square. So this one and this one is cancelled off. So we get back the x squared plus 6x only. Right? Okay. So this is the answer. So x squared minus 10x, same thing. X minus 5 square because 10 divided by 2 is 5. And then minus of 5 square, minus of the third term in our expansion. So we get x minus 5 square minus 25. Here is x minus 3, sorry, x plus 3 square minus 9. And then for here, we have x square minus 5x. So it will be x minus 5 divided by 2 square minus 5 divided by 2 square. Is it confusing? Can understand? Or which part? Do you need me to explain any part? The fraction part. Okay, so because 5, I told you before that when you trying to do the completed square thing, right? The second term here, the coefficient of x, you just need to divide by 2, right? So 5 divided by 2 is just 5 over 2. Lor. So actually, are you familiar with this expansion? The one where you have like the a plus b square is equals to a square plus 2ab plus b square. This one? You have seen this before? Yeah. So this one is matching with here, then you need to minus off the b square. Okay, so maybe for the second question, you can try to do this one and then you key in your answer. I give you some time to do.